Hey, before we get started, I want to let you know that the Premed Playbook Guide to the MCAT is now available for pre-order or available to buy on Amazon and Kindle, paperback and Kindle, if you're listening to this later. But the Kindle, right as this moment, is available for pre-order. The paperback is coming soon, if it's not available yet, as you look. But this is the book to buy if you are just starting out on your journey. You're listening to the MCAT podcast because you're trying to get ahead, but you need to understand what the MCAT is all about. The Premed Playbook Guide to the MCAT is basically the MCAT podcast boiled down into a book with a lot more information in there as well. So go check that out at mcatbook.com. This is the MCAT podcast, session number 92. A collaboration between the medical school headquarters and Next Step Test Prep, the MCAT podcast is here to make sure you have the information you need to succeed on your MCAT test day. We all know that the MCAT is one of the biggest hurdles you'll face as a pre-med. We're here to give you the motivation and information that you need to know to help you get the score you deserve so you can one day call yourself a med student. Get that acceptance. Welcome to the MCAT podcast. My name is Dr. Ryan Gray, your host here every week. As always, I'm joined by Brian Snedeker from Next Step Test Prep. And together we go over almost everything, or hopefully everything, that you need to know for the MCAT. Some weeks we cover questions. Some weeks we cover passages. Some weeks we cover general information. Next week we're covering the new data that came out with the updated MSAR and what that means for you. But this week we're continuing our fourth and final week of physics, talking about some fluid dynamics. All right, Brian, our last week of fun with physics here on the MCAT podcast. This is session 92, covering our fourth week of physics, broken up with our week of content versus test skills question. So we've done springs, we've done light, and we've done fluid. What's our fun trick this week?
Well, I wanted to go back and maybe do just a couple more fluid questions to wrap it up because, when we look back at it and I think about kind of the feedback I always get from my students, it really always ends up coming back to buoyancy and density, and fluid students just have so much trouble with it, and it's so medically relevant because they can ask questions about the blood or the action of the heart or the fluid lining the alveoli of the lungs. Very, very important on the MCAT. So I thought we'd wrap it up with some more fluid questions.
And the way you frame that about the blood and alveoli and stuff like that, it's not like the MCAT is testing your anatomical knowledge, but they're having fun with framing the questions of physics and other things just around the body. Mm-hmm. Right?
Well, for some value of fun.
Yeah, for fun. Yeah, define fun. All right, yeah. So it's not like when you hear that, so the first thing that jumped in my mind, the student is going to hear what you're saying and go, "Oh, I need to go take anatomy and physiology." That's not what we're saying here.
Mm-hmm.
Okay. Right?
Yeah.
All right.
Correct.
Okay. So again, you can follow along in the show notes, session 92 at themcatpodcast.com. Question 14, a billiard ball is submerged in a small tank of water at a depth of exactly 60 centimeters. However, the tank is located in Denver, Colorado, where the ambient pressure is roughly 0.83 atmospheres. What is the absolute pressure experienced by the ball? A, 6,000 pascals, B, 6,830 pascals, C, 84,245 pascals, or D, 90,245 pascals. Yeah, I'll let you take this over.
Sure. So when they asked you for the absolute or total pressure, so that means you have to add atmospheric plus what we call gauge pressure, which is the pressure that you get from being underwater or submerged in any fluid. So in this case, they said you're in a tank of water, you're at a depth of yada, yada, whatever. So there's some amount of gauge pressure here. Okay. But let's start with the atmospheric part, because that was, I often peel these questions apart backwards. Start at the end of the question, what did they actually ask you, and then work backwards from there. So 0.83 atmospheres. Now, one of the things you got to walk into the test knowing is that an atmosphere is 101,000 pascals. It's 101, 325, but you just that's a conversion you got to know. Like, just round it off to 101,000. So the first thing you could do is look at this and say, well, 0.83 atmospheres times 101,000 is already going to give you about 84,000 pascals. Mm-hmm. Give or take. And if you had paper and pencil, or nowadays laminated board and marker, like you do at the Pearson Centers, right? Like you could do it out by hand just to get the exact number. And you look at these answer choices and go, all right, well, 6,000 clearly wrong, 6,800 clearly wrong, 84,000 and 90,000. Well, those are clearly, it's got to be one of those.
Okay.
And if you're gonna, if 0.83 atmospheres by itself is already going to give you about 84,000 pascals, but you also have to add the gauge pressure, then probably the answer is D, 90,000. Like 84,000 is just the atmosphere. And so you beyond multiplying 0.83 times 101,000, you don't actually have to do any more math.
Okay.
Now, if you really want to do the math, the gauge pressure is rho g d, rho the density, times g gravity, times d depth. So you would do, gravity is 10 meters per second squared, the depth, what did they say here? 60 centimeters, so 0.6 meters. We're working in SI units, so the density of water is 1,000 kilograms per cubic meter. Yeah, so on and so forth. I mean, you could do all the math out, but you really don't need to. You just go, well, it's 84K plus a little bonus extra. So 90K is the only answer choice that fits.
And what I can see a lot of students doing, because I talk to a lot of you guys out there, I can see the student going, I need to know for sure. And they'll waste the time doing the math when they could be moving on, making sure that they finish all of the questions in that section.
Mm-hmm. Yeah, it's the MCAT is very much about answering with 100% confidence when you're only 70% of the way there. It's the only way you're going to get through the section in time.
Yeah, that's hard for a lot of the Type A pre-med students.
Mm-hmm. Well, that's why the test lets you have they call it flagging. You can click a little button to flag a question. So on a question like this, you would put D, 90,000 pascals, flag it, and move on. And then if you have the time, you come back and do the flagged questions.
Oh, that's a good way of doing that one.
Mm-hmm.
Okay.
Yep. Okay, next one. 20 milliliters of an unknown fluid is added to an empty test tube, resulting in the situation pictured below. For this fluid, the picture shows a test tube with your typical meniscus, where the fluid is kind of crawling up the sides of the test tube. So the meniscus has the bottom, the lowest point of the meniscus is in the middle of the fluid, the middle of the cross section, and on the edges, it kind of crawls up the sides of the test tube. So then the question is, for this fluid, adhesive forces between the fluid particles are greater than cohesive forces between the fluid and the glass. B, adhesive forces between the fluid and glass are greater than the cohesive forces between fluid particles. C, cohesive forces between fluid particles are greater than adhesive forces between fluid and glass. Or D, cohesive forces between fluid and glass are greater than adhesive forces between fluid particles. So what do you think, Ryan?
So you have to know what adhesion means and what cohesion means. And so I think that's the first step that a student has to know. And I'm a very quick Googler. And so I now know that adhesion refers to clinging of unlike molecules. And so to me, unlike here is the fluid and the test tube being the unlike particles. And so that's telling me that the adhesive forces, I think, are greater between the fluid and the glass than the cohesive forces between the fluid particles, which is why they aren't going up as high. And so that would give us answer choice B.
Yeah, and that's exactly right. Yeah. So remember the co at the beginning of cohesion, it kind of is the clue that it's like things being together, right? Like coordination, cooperation, cohesion.
Okay.
And an adhesive, right? It's like glue to stick two separate things together.
Yeah.
Yep. And so in this case, the fluid is crawling up the sides of the test tube, right? So clearly the attractive force between the fluid and the test tube is the stronger thing.
Okay.
Yep.
If only you could Google while you're in your MCAT.
Oh my God! Could you imagine what the scale would be like? You got one question wrong for 73,
and you don't get into med school. Yeah. All right. Question 18. A salt solution with a density of 1,075 kilograms per cubic meter is moving through two consecutive closed vessels. Both vessels are positioned at the same height, but the solution travels twice as quickly through one, vessel A, as the next, vessel B. If the pressure exerted by the fluid on the walls of vessel A is 6,000 pascals, the pressure exerted on vessel B is A, 3,000 pascals, B, 6,000 pascals, C, 12,000 pascals, or D, a value that cannot be determined. And so a couple weeks ago, we had our value. We need more information, so I would love for it to be this one, but I'd assume it's not. So we know that the solution is traveling twice as quickly, which means it's traveling through A than B. And so we know that the pressure on A is 6,000. So we need to know the pressure on B. And if I remember randomly correctly, without Googling, because it's traveling faster, the pressure is going to be lower, if I remember correctly.
Yep.
So it has to be less than 6,000 pascals.
Well, no. So it's faster in A, and the fluid in A is at 6,000.
Okay, yeah. Okay, faster in A. So it's in B, which means that the pressure is slower. The fluid is traveling slower. And so the pressure is going to be greater. So it's A is 3,000, which is lower, so that's not it. B is 6,000, is the same, it shouldn't be it. So it's either C or cannot be determined.
Right, okay, so you got it down to a 50-50 with exactly the right logic. That's perfect. So, of course, on test day, you would just take your guess and move on. And so in this one, Ryan, actually, your instinct was incorrect. Like you didn't want it to be D, but in fact, D is the right answer. The reason I picked this question, just to kind of wrap up our physics universe, or really, in addition to just talking about fluids, is emphasizing with the first question we did and now with this last question that so much of what students are scared of on physics is, I have to do all this math. And yet so often it's not the math, that it's just conceptual use of the equation, right? You have to know what the equation is, but you then don't actually have to do any calculation. And in this case, with density showing up, with height, it mentions they're at the same height. It mentions speed. It mentions pressure. You're using Bernoulli's equation, which just says that the pressure at point A plus the height at point A, it's actually rho GH, but so pressure plus height plus velocity, it's actually 1/2 rho V squared. But so pressure plus height plus velocity at point A has to equal the same thing at point B. Pressure at B plus height at B plus velocity at B. The equation has some more variables in it, but that's basically it, is that what influences pressure is the height and the velocity. But here's the tricky bit. It's those plus signs, right? So if it were all stuff being multiplied together or divided, then you could say something really simple like, it travels with twice the velocity. So that means it has half the pressure or double the pressure, or if it's a squared relationship, quadruple the pressure. But because you're adding these various terms together, it doesn't translate then into a perfect direct relationship. So, for example, I mean, if you take Bernoulli's equation, pressure at A plus rho GH plus 1/2 rho V squared, all at point A, and that equals all at point B. Now, you can drop out the height term because the question said they're positioned at the same height. So then you've got pressure at A plus 1/2 rho V squared equals, X, or pressure at B, which is what the question asked us for, plus 1/2 rho V squared at point B. You can then, they told you what the density was, so those rhos are unknown. But then it told you what the ratios of the velocities were. So you could say, okay, well, one velocity is, let's just say, V, and then the other velocity is 2V, right? You can just put the ratios in, but then you're still left with an equation where it's, 6,000 plus 1/2 rho V squared equals the unknown X plus 1/2 rho 2V squared, double the velocity. But you still have two unknowns, right? You have the X unknown, which is what you're solving for, and you have the velocity unknown. Now, the way that you usually handle this when you have multiple unknowns in a problem is you just divide the X over to the other side of the equation, or divide the whatever you're doing, like PVNRT, divide the P, the V, the N, the R. Divide the variable to the other side, and the variables will cancel each other out, and then you can actually solve it, right? So one ratio can give you another ratio, and there's your answer. But here, the plus sign in Bernoulli's equation just throws a whole monkey wrench into the works there, where if you tried to divide velocity over, you'd end up with, multiple wacky ratios separated by plus signs. So you can write out the whole equation, and after the podcast is over, and you've parked your car, right? If you're listening to this while driving, write out Bernoulli's equation, try and solve the question out, and then come back and listen to the podcast again, so you can kind of hear what I'm saying about how the math doesn't really work here. But the important point is, don't be afraid of the answer choice cannot be determined, because maybe it really can't be determined.
Okay. So I have, before we wrap up, this was the last question here. I have a question that has been bugging me that I know you can answer.
Okay.
And the question is water wet?
That sounds like some sort of semantic game rather than...
No, it's physics, man. It's all about physics. Come on. Is water wet? What's your initial thought on that?
My initial thought is I would have to look up the definition of the word wet,
okay,
to see if what exactly, how that's meant.
Yeah.
I would assume in most common sense understandings, the answer would be yes. Is there some sort of tricky physics understanding where the answer is no?
Well, I think when you actually look up the definition of wet and what water is a molecule, obviously, then water itself is just a bunch of water molecules and doesn't make things wet, or isn't wet, but water on a surface, the definition of that is then wet. So water itself is not wet, but when it's on a surface, then it is wet. So, well,
there you go. You learn something new every day.
It's a fun thing that I've seen online a couple times, and I love seeing the thoughts going back and forth. I thought it'd be a fun way to wrap up a not fun subject block here on the MCAT podcast.
There you go.
All right, there you have it. Again, some fluid dynamics with Brian Snedeker from Next Step Test Prep. If you haven't looked at Next Step Test Prep for their full-length practice exams, you're missing out. They are known in the pre-med world as probably one of the best companies out there for practice exams, right behind the WMC. When you use Next Step Test Prep practice exams, you are using the real-life, fully simulated environment that you're going to be in when you go to your Pearson Testing Center to take the MCAT. Everything that you do, the way you use your mouse, keyboard shortcuts, the way that the software looks is all exactly the same as it is with the Pearson Testing Center, the real MCAT. So rest assured that when you're doing your full-length exams with Next Step, you are practicing in the best environment possible. Go check them out, nextsteptestprep.com. testprep.com. Use the promo code MCATPOD. That's all capital letters MCATPOD to save a little bit of money. Hope you have a great week. We'll see you next time again when we talk about the updated MSAR and what that means for you.